Myself, Vanan. I'm a tech lead at RCCM. Today I'm going to talk about cloud native multi-cluster or multi-cloud load balancer. Sorry for a technical glitch. I have a thought of giving a hands-on demo, but let's see how far we can go with that. If you see GLB or GSLB is a common industry term, which means global load balancer or global service load balancer, which is a common terminology which is used in industry to denote steering of traffic across multiple geographies. Okay, it might be a different setup across multiple cloud providers or across multiple regions or between your on-prem to your cloud actually. So KGB is a Kubernetes global load balancer, is a CNCF Sandbox project. It is used to route traffic across multiple clusters. Those clusters can be set up on multiple cloud or between your on-prem or your cloud as well actually. Okay, these are some of the key differentiators or benefits I could see in KGB or Kubernetes global load balancer. I could see it can work on any existing Kubernetes cluster actually. For multi-cluster traffic management, there are a lot of different solutions. Some CNIs will provide multi-cluster load balancer, or a service mesh has the ability to do a multi-cluster load balancer, but there are some prerequisites to use actually. But let's say you have an existing cluster and existing ingress which is already set up and running, and you just want to do a multi-cluster load balancing on top of it, and you can consider KGB as one of the best candidate for it. And in general, people go for a multi-cluster or GSLB sort of solution for a HA or a disaster recovery use case actually. And in this one, there is no dedicated management protocol, or there is no dedicated control plane as such, so there is no single point of failure. And it uses the Kubernetes health checks to propagate the endpoint availability to the DNS actually. And if you see, like, it uses the DNS protocol to do the global load balancing actually. And then it uses yet another CRD actually. There is something called GSLB kind object which will be using to create these objects actually. Okay, so once you this is a kind of architecture or how it will look like when you have a KGB is getting installed in your machine actually. So basically you have an application spot, and if you want to expose to external world, you will be creating an ingress object actually. So in this case, you will be creating an GSLB CRD object that in turn creates an ingress object actually. So there are two ways to do it actually. You can either go for you can create a GSLB CRD object, or let's say you have an already set up cluster which has the ingress which are running. You can use GSLB annotations on top of the existing ingress. In both the cases, the KGB controller will watch for those changes and creates the DNS endpoint CRD actually. So along with the KGB controller, it has two more. It uses the two more components actually. One is core DNS actually. So in KGB namespace, it will install a core DNS instance as well, and it has a plugin where it can read the endpoints from the DNS endpoint CRD actually. And KGB is also using a SIG external DNS project actually, which is used to configure your upstream edge DNS server actually. It can be in any, if you see, go and look on the external DNS project, it supports wide variety of DNS providers actually. You can, if you have an on-prem DNS or edge server, you can configure that too as well. So basically that's how it works actually. So the KGB controller will in turn creates the DNS endpoints CRD based on the application health check on the whether the ingress IP is updated on the ingress status object. So DNS endpoint is updated by this KGB controller. That can be core DNS will listen for those changes and updates the A records actually. And the external DNS, what it does is like it does the zone delegation actually. Basically, whenever an DNS query comes for your edge DNS server, it will forward those queries to the zone delegation in such a way that the core DNS running in your KGB namespace will resolve those queries actually. Okay, so for this use case, I have considered two clusters actually. Let's say there is a cluster US and EU. From the previous slide, we get to know how this will work for a single cluster where it can able to read the endpoints from the ingress and updates the core DNS, and we have a zone delegation so that any DNS request for your edge server, it will be forwarded to your core DNS instance which is running on your cluster actually. But there might be a question how it can able to discover the endpoints which is spread across the cluster actually. Since I mentioned there is no dedicated control plane, it uses the same DNS protocol actually. So in DNS there is something called RFC 2136 where you can transfer the zone files across your name servers and you can able to validate actually. So in KGB controller there is a recursive reconciliation loop. What it does is like it will try to from the edge server it is trying to get the NS records actually, and from the NS record it can able to get the other name server which is running on other cluster, and it will try to resolve the local targets present on those clusters. And if it is able to resolve, it updates the DNS endpoints here. If it is not able to resolve or this cluster itself down, right, it can't able to reach this name server. So what it does, right, it will update the DNS records accordingly actually. So with that, I have explored other vendor projects which offers GLB, but what the prerequisite is like you have a bulky control plane which is used to transfer the state actually, but comes with KGB, right, there is no dedicated control plane and it works in a cloud native way. Let's try to play the demo recording actually. So I thought of giving a live hands-on demo so that it will be much more interesting. So I have set up few clusters in my laptop using K3s, but I don't think we can do it now. So meanwhile, if you have any questions, you can feel free to ask me. Sorry? Sorry, I couldn't hear you. Yeah. Yes, actually there is a geotagging is also available, and there are different strategies you can, when you configure a GSLB, right, you can have a different strategies. One is geotagging, like whenever a client comes in, which it will try to connect to the closest cluster you have, and if there is a failover policy, if that cluster is down, your traffic is routed to the other cluster, and once the primary cluster came up, it will route the traffic to the geotagged location actually.
Hello. Does it have a service-based load balancing as well, or is it only to cluster?
Actually, it is. Can you just repeat your question?
Service-based load balancing. So, say I have an external namespace services, 4 services, having a same single path direction with the ingress controller. So, can it do a service-based load balancing?
Yes, if your service has external name actually, basically if you have service and it has an external domain name configured, yeah, definitely you can able to do that actually.
And what all the protocols it can support?
It basically it supports only HTTP. This is based on DNS, right? If your service is as a UDP, and definitely it supports, but usually by default it supports ingress object. So since ingress doesn't support UDP, right? But if you configure your service in such a way that external name, but that requires some manual configurations actually, it doesn't work out of the box.
So actually, it does do a round robin kind of protocol between the 4 services?
Yes. I mean, there are different strategies available. Yeah, round robin is one of the strategies, and there are some failover strategies actually.
Okay, cool. Thank you.
Yeah.
Hi, quick question. So have you tested this across multiple clouds, this side?
Yeah. Basically, but you need to have your edge service, which should be common in one place, or and you can have your clusters which can be running across multiple clusters, but you make sure your name server and your service IP is reachable, and it should be reachable across the cluster. Yeah.
So 2 different cloud. How will the name server? Okay, the name server has to be reachable, so it can be on one cloud.
Yeah, it should be reachable on port 53 with UDP port should be exposed actually. So If that is available, yeah, definitely.
And let's say in one of the clusters I'm using ingress and in other I'm using some other method, it doesn't matter.
I mean, so I couldn't get you the
so
other
for
question.
one cluster I'm using ingress controller as a network management and service access. For other I'm just trying to access something over a node port. Would it still work?
I mean, if you have the ingress object defined with the same host name for both the services, it should work.
So this works at a host level?
Yeah.
Okay.
Yeah, okay. Actually, if you see external DNS SIG, it's a open source SIG project actually. It provides wide variety of options to configure your upstream DNS server actually. So Route 53 is one of the provider in that. What it does is like it configure your Route 53 to delegate the queries to the core DNS which is running on this instance actually, in the cluster actually. So we are not having the A records in the Route 53 your domain actually. It will just delegate the zone. It will have NS record actually. NS record is something, yeah. It will add your core DNS as a name server actually. Otherwise, if you update the Route 53, right, there will be a API rate limiting. A lot of things comes into picture. So and the recovery also in case of DNS, right, it takes time to propagate the changes, right. So instead, if you set up a zone delegation, it is easy to update the DNS endpoints. Yes.
Service.
Yeah, it is happening through the zone DNS server actually.
Zone DNS.
I mean, we have a zone, we have a core DNS instance which is running across cluster, right? That will do those round robin and the.
So request is going from route.
Yeah. Basically, the edge will just forward the queries to this zones actually. Basically, this core DNS instance. So that will take care of how we are going to do the strategy, whether it's a round robin or weighted or a geotagged approach.
Okay. So Route 53 you are using for the public propagation, and then it's routing the traffic to there. Okay.
Tamil, I think like we overran the time a little bit. Do people want to use this as a Q&A or like actually go with the demo? Just a quick show of hands if you want to continue with the demo or continue with the Q&A. See some demo? Okay, cool.
You can make it 2x so that it should be. So for this, I have taken 3 clusters I have installed in my local laptop actually. So one is a Edge DNS which I have running a bind server actually, and the other 2 are the demo cluster where I was running an application which I want to do a load balance across the clusters. So basically I was just checking, once you install this KGB controller, you can see this instance of pod is running. One will be an external DNS and the KGB controller and core DNS. And I was using Ingress Nginx as my controller, so Ingress controller. So you can see the Ingress controller pod as well actually. So in both the clusters, it will be the same actually. So I was just moving to the test namespace where I want to create this GLB actually. So I have one service which is called front-end pod info, which is deployed, which is created as a pod, and I have exposed as a service here actually. So I was just checking whether it is present on both the clusters. So it is present on both the clusters. So I'm going to create a. So I'll make sure there is no ingress object which is already created. Okay, so if you see the spec, it is more of a ingress spec. You can have an ingress spec. In addition to that, it have something called strategy. So someone have asked a question. So you can, whatever strategy you want, you can update it here. So by default, I was using round robin. there are other strategies like failover and weighted approach as well actually. So, and DNS TTL second is something how fast you want to propagate your DNS updates. So this needs to be, you need to create this object in both the clusters actually, so that both the controllers can able to understand that for this host name you are going to do a GSLB. So once you have this GSLB object created, we can make sure you have a GSLB object is created and the strategy is updated, and you can go and check the ingress object whether you have the status is updated with the ingress IP as well. And if you see, I have tagged my first cluster as EU actually. When you install KGB controller, there is an option to tag the cluster which region you want actually. So in this case, I have tagged first cluster as EU, the second cluster as US actually. Now you can check for our demo host name kcdcloud.example.com. I have the ingress is created, but it's still waiting for to get the IP actually. Meanwhile, we can check the status on the other cluster as well. So once you have this ingress updated, so what a KGB controller does, right? It will create one more CR object actually, which is a DNS endpoint object. That's what the core DNS and the external DNS will make use of it actually to update the edge server actually. So if you see here, I have a targets. The targets in the second cluster is not updated because we are still waiting for the ingress to be created for it actually. Okay, now I think we got the IPs for the second cluster as well. I think this DNS endpoint should be updated with this both the addresses actually. So this propagation is happening over the DNS protocol itself actually between these clusters. So even if the one cluster completely goes down, it will work, but we make sure the DNS should not be a single point of failure. Whatever edge DNS you are using, it should be highly available. That's the prerequisite for this one. So I was just creating a busybox pod for running the traffic. So in the busybox, I have configured my edge pod as the edge pod service IP as my DNS server actually. So I was just trying to do NS lookup so that we can check whether we are able to get the IPs are resolved across both the clusters actually. So we can see the entries for both the clusters. Let's try running some traffic as well and do some failover. So I have deployed both. So if you see, the traffic is routed between the pods which is spread across the cluster. So from the message you can see one is US and other is EU actually. Let's go and set the replica to 0 for one of the pod actually. So let's take cluster 1 and set the replica to 0 so that the traffic is routed to only to the US cluster, and let's see how it works. So if you see, so for EU cluster there was a blip actually. We can see some 503 because it resolved it, but the pod is not available. But since we have set the DNS TTL as 10 seconds actually, so it will take some time to propagate those DNS endpoints actually. And if you see now, I think it always routes the traffic to the US cluster actually. Let's try and set the replica to 1 to make sure the traffic is routed across both the clusters. It'll take some 10 seconds to get the further DNS propagation. So if you see right now the traffic is routed between the US and East now actually. Yeah. So this is a KGB Slack channel. You can feel free to join, and this is a very active community. If you have a doubt, you can make use of this channel. And the demo setup is available. You can install it in your local machine. And this is a GitHub research page as well. If you have any doubts, feel free to contact me as well. We no need to have a separate ingress. Let's say if you are using other than NGINX, let's say you are using a different ingress controller, you need to use the GSLB annotation instead of a GSLB CRD object actually.
Thank you so much, Tamil. That was like great.
Sorry guys, sorry for the technical glitch. So.
You did great. Thank you.